So how do we determine the depth? We either need the real coordinates of the points or additional angles of the same location. In other words, regular reference photos. And let's go through the second method, working with reference photos. We add a new reference camera and load into it a photo taken in the same location but from a different angle. What do we do next? We project the tracked point into the reference frame. We go to the main camera, select a point, for example, this one on the corner, and then we need to switch to the reference photo without losing the selection. If you double-click with the left mouse button, the selection will reset and you'll have to remember which point you picked. So we do it differently. Double right-click on the reference camera or right-click once, switch to this reference camera. This way we switch to the reference camera and the selected point stays active. Here's an important detail. To switch between cameras without losing the selected point, both clicks really do need to be with the right mouse button. Select the point in the main camera, double right click the reference camera, or right click, switch to this reference camera. The selection stays active. Next, we switch to mono tracking mode and place the point in the same spot on the reference photo. The point is already selected, so we just left click the correct location to create the corresponding key. We repeat this for all other trackers that are visible in the reference frame. We select it with Alt and we place the points. This way we give the program the missing parallax. Even though the shot itself has no parallax, the view from another angle makes it possible to understand what's closer and what's farther. Let's solve it and see what we get. Here's our main camera, and here's the reference one. And we can see which points from the reference frame match the points in the main camera. We got a pretty good result, I think. Let's take a look. Let's check it in 3D orientation. Let's try to figure out what's what. It looks like this point is the farthest. We select it, switch to lineup. Nope, not the farthest. Alright, we'll sort it out. Let's check where these 2 points are. Well, they're somewhat close to the truth. Our scene orientation is incorrect. The floor clearly isn't lying where the floor should be. There are a couple of ways to fix this. For example, we can select the points that lie on the floor. 1, 2, 3. I'm selecting them with Alt plus Shift. All these points sit on the floor. With them selected, we go to 3D orientation, open Edit, align 3, 2, and choose the plane we want to place these points on. In our case, that's the XZ plane, the ground plane. The other menu items move the selected point or points, either to the origin or onto a chosen plane, or they lock them along an axis, depending on what you need. Right now we selected 3 points and placed them on a single plane. Let's take a look. They're on the same plane now, but not at 0 on Y. To move them to 0, we do this. We select the point we want to place at 0. I'll take this one. And through Edit, move 1.2. Origin, we move it to the origin. And this is what we get. The scale is still unclear. How do we set it? We can select 2 points and set the distance between them. 3D orientation. Constrain, create distance constraint. I know the distance between these points is 45 centimeters. And set The scene has changed in scale. So the origin shifted because of that, and we can place it back. What's good about setting the scale and orientation this way? The fact that this kind of orientation doesn't affect how the scene was solved. If we have only one distance constraint, then any move 1.0 or align operations simply reposition the already solved scene relative to the selected points. It's a pure translate and scale operation without modifying the camera solve itself. But if there are multiple constraints, then the scene must be recalculated, and that will affect the solve. There's another way to set scale and orientation, specifying the actual coordinates of the points. That's more accurate because those coordinates take part in the camera solving process itself rather than placing the scene on top of an already finished solve. So let's say I know this point's coordinates and I want it to be at the origin. I know the distance from this corner to the wall. It's 2.6 meters, and instead of setting it with a constraint, I enter its coordinates. From the point that's at 0, this one is at minus 260 centimeters on X, 0 on Y, and 0 on Z. And this point here, same minus 260 centimeters on X, 0 on Y, and 120 centimeters on Z. These are measurements we take starting from the chosen origin point. We set one point as 0, and from there we measure the distances to the other coordinates and points. And now the scene is oriented differently. It now has a proper scale. And in terms of depth, we can see that this point is the bottom corner of the fridge. And that this point here is our origin. Here it is. And I think the rest are placed pretty much correctly relative to it, more or less. That's how it should be. And that's how we determined the depth in a scene that would have been impossible to recover without a reference photo and without the extra information from the point coordinates. A few more words about the distance constraint, the scale we set in the scene. Here we told the program that the distance between these 2 points is 45 centimeters. To edit this value, we go to the point group where the distance constraint was created, expand it, and we can see everything inside the group. Points, the very points we tracked, here they are. These are 3D models you can load into this point group. We'll go over them in the next lesson. Geo objects are auxiliary lines and objects you can place in 3D space for orientation and alignment. We'll come back to them later. And constraints are those very constraints, for example, distances between points. Here is the distance constraint we created. We can right-click it to edit its parameters, disable it, or delete it entirely. Let's continue. So, when a scene consists of several shots filmed in the same location, all of them must be tracked in one coordinate system. If we created a project and tracked one shot from that location, then created a new project for the next shot, and another project for a third one, then all 3 solves will live in their own separate coordinate systems. The camera in each project will end up in a different place. The points will be in different places too, even if we track the same objects, because one shot has almost no parallax, another is static, the third has good parallax. So the scene will float every time because each solve is built from different conditions. This doesn't work for us. If we're building an asset or geometry and want to place it correctly once, then we need all shots of the location to be solved in the same coordinate system, so the asset doesn't jump. How do we do that? There are a few ways. Assign the same real-world coordinates to the same points in every shot, like we just did. But this requires that the same trackable points are visible in every shot. Use photos or LiDAR to define shared geometry. Or, the most convenient option, load all the shots into a single project and track the same points in each shot, so the software itself aligns the cameras. We'll do exactly that. I have another sequence filmed in this same location. Let's add a new sequence camera and take a look. So if we track this shot separately without using the same points, it will just be a second camera that has no relation to the first shot at all. To use the data already solved for the first shot, including coordinates, the reference photo, and everything else, we need to use the same trackers. Then both cameras will be solved based on the combined information we provide. We switch to the camera and select one of the points, for example, this one, and solve it for the shot. So we also need about 6 points between the root frames and at least 4 across the whole shot. First, we'll try using only the points that are already used in the tracked plate, because they already contain some information. By tracking them from another camera, we're essentially enriching these same points with new data instead of creating new trackers that we know less about. You can press enter. This switches between the sequence cameras. It's a very convenient way to check whether we're looking at the same point. Here's the first camera, here's the second. We keep an eye on the direction because we tracked that point backward, and this one we're tracking forward. We check that we're roughly in the same spot and track it. Alright, and at least one more, so the next point. Let's see how the tracking goes here. I don't think it'll be great, but we'll check. Let's get to this moment and set a keyframe. Everything looks fine up to here. We'll change the settings. I'll turn off rotate, keep scale, and see how that works. We go up to the point where the tracking still holds at least a little. We try using a more contrasty pattern that usually gives a slightly more stable result right away. We'll track a bit frame by frame. But it slides across the white surface, which isn't great. I'd prefer not to switch to fully manual tracking here. The rather low image quality is taking its toll. But I think we'll manage. Here in the background a line appears. Better avoid it so it doesn't throw the track off. Something like that. To repeat, the point is that we're projecting in this shot the exact same points we tracked in the very first shot and placed on the reference frame. Alright, a couple more points. Let's create a new tracker. And create another one. We go up to the moment where everything still holds. Looks like I accidentally created a new point instead of tracking the same one, meaning I lost the selection when switching to the second camera, so we'll have to delete it and redo that step. Select point 1 and track it. Of course, the first thing I want to check is whether I accidentally did the same with the other points from the previous set. And track it. And in a way that's enough for us. We can take one last point, for example, this one here, and track it. And place it in the remaining spots. So in this shot, it's also selected. That's point number 20. Alright, let's check whether all the created points exist in all sequences. And it looks like I created this point as a new one too. Let's delete it. This isn't a rare mistake, so it's really important to double check yourself. Point 6. Here it's placed correctly, but in the sequence it's wrong. Alright, looks like everything is fine now. And we can place it here as well, in the reference frame. The main thing is to double check 10 times that the same point is actually selected. Here it is, visible right here. Here it is, point number 14. And now it will appear here. We just left click to place the already selected point instead of creating a new tracker. Solve it. And now we have 3 cameras in one shared scene. The first camera, the upward move. The second camera, the drive-through in the same location. The third, the reference frame. They all use the same points, so all geometry and depth are now consistent across them. If we switch to lineup, we'll see that any selected points line up in the exact same place on the image across all cameras. Here they are. And here. Even though this tracker isn't tracked here, we can scroll through the timeline and see that overall the point stays in place. We can adjust it if needed, but even with this setup, we didn't track that corner in the second shot, and it still ended up roughly in the right place. The same goes for the other points we didn't track in this shot, but did track in the others. Thanks to this shot, we can refine their positions, and it's already clear that this point is defined right here. We center in 3D, and overall it matches reality. We didn't track this point in this shot, but we know it sits on the corner. And here it's more or less on that corner. Ideally, we'd refine everything manually, but this already gives us the general layout. This is how you track multiple cameras in one scene, either with reference photos or without them. We could just as well build the same scene from several reference photos first, projecting the same points, and only then track the actual shot. There are different workflows, but the principle is always the same. We take everything we have that was shot in this location. Not literally everything, only what actually helps, usually the same objects filmed from different angles. And we track all of it in the same way, regardless of whether it's a still frame, a reference photo, or a sequence.